Correlation describes the direction and strength of a linear association. The key here is that it's talking about a linear association. The formula for correlation is the following. You'll notice in the numerator you have the sum of the x minus x bars over s sub x times y minus y bar over s sub x. You will notice that this is the formula for the z-score. So what you've got is the sum of the z-scores for the x's times the z-scores for the y's, divided by n minus 1. Turns out correlation will always be a number between -1 and 1 inclusive. If r is greater than 0, then you have a positive linear association. If r is equal to 0, you have no linear association. And if r is less than 0, then you have a negative linear association. Now, if the absolute value of r is greater than 0.8, the general rule of thumb is that it is a strong relationship. If it's between 0.5 and 0.8, that's considered moderate, and anything less than 0.5 would be considered weak. So, in our examples, in terms of how much scatter we have, in this first one we had a lot of scatter, so you notice that r is equal to 0.4, which was a weak relationship. Since r is close to 0, you would expect to see a lot of scatter. In the second example, which was moderate, r is equal to 0.7. And in the last example, where it almost looks like one line would hit every one of these dots, you have r equals 0.99. For it to equal 1, a line would have to hit every dot in the scatter plot. Outliers. What we want to do is look at our scatter plot and determine if we have any outliers. You'll notice that we have, in general, the body of the scatter plot over in this direction, and then we have this one point. This one point would be considered an outlier. So to be considered an outlier, a box plot of the x and y values should be plotted. You can see that this dot isn't really in the general area of the rest of the dots. So that would be considered an outlier. But you can prove it by drawing box plots. So I've done a box plot of the x values, and you can see that that point would be considered an outlier. I also did it for the y values. So this point is outside the general range of the x values as well as the y values. We must be very careful in interpreting correlation coefficients. Just because two variables are highly correlated does not mean that one causes the other. In statistical terms, we say that correlation does not imply causation. There are many good examples of correlation which are nonsensical when interpreted in terms of causation. Ice cream sales and the number of shark attacks on swimmers are correlated. Skirt lengths and stock prices are highly correlated. As stock prices go up, skirt lengths get shorter. The number of cavities in elementary school children and the vocabulary size have a strong positive correlation. Three relationships which can be taken or mistaken for causation are causation, changes in x cause changes in y. For example, football weekends cause heavier traffic, more food sales, etc. A common response. Both x and y respond to changes in some unobserved variable. All three of our examples are examples of common response. Ice cream sales and shark attacks both increase during the summer. Skirt lengths and stock prices are both controlled by the general attitude of the country, whether it's liberal or conservative. And the number of cavities in the children's vocabulary are both related to a child's age. The third one would be confounding. The effect of x on y is hopelessly mixed up with the effects of other explanatory variables on y. For example, if you are studying the effects of Tylenol on reducing pain, and we give a group of pain sufferers Tylenol and record how much their pain is reduced, we are confounding the effect by giving them Tylenol with giving them any pill. Many people report a reduction in pain by simply being given a sugar pill with no medication in it. This is called the placebo effect. To establish causation, a design experiment must be run. So, association, relationship, and correlation does not imply causation. However, causation does imply association, relationship, and correlation.